Welcome to this week's midweek Space Startup News. As usual, I'll be going over some articles I found on space news websites and on social media posts. First of all, we're on X. You can follow at Space Startup Hub, and I post links to my YouTube videos on X. So with that, let's get into the first article of this week, and this is on Vast Space. So Vast, builder of private space stations, is launching its line of high-power satellites. And I've highlighted a few sections of the article, and as usual, you can find all the links in the video description. Vast isn't just about private stations anymore. They announced yesterday that they're going to build satellites as well as space stations. High-power satellite buses built for operators across communications, Earth observation, national security, and orbital data center satellite constellations. So this is another space startup that is moving into orbital data centers, just like Etherflux, with a change of name to Cowboy Space, and SpaceX and Blue Origin and Google and perhaps many other companies are all moving towards orbital data centers. So it's looking more and more likely that orbital data centers will take off in a big way in the next couple of years. So carrying on with the article, they will leverage technology that the company has already demonstrated in space on a test flight called Haven Demo. And it goes on to say Haven Demo turned out to be a pathfinder for Vast satellite as well, because Vast builds its core systems in-house and will use them for the newly announced spacecraft buses too. And Vast already has a customer that's committed to buy 4 satellites with an option to purchase 200 more. The Vast satellite is based on a 15 kilowatt class bus designed to support a wide array of power-intensive missions through flexible configurations, according to Vast. And it will operate for 5 years in low Earth orbit. Vast plans to launch a batch of these spacecraft, 10 of them, to orbit for the first time in late 2027. And at the same time, the company continues to work on its Haven project, which aims to have the multi-module Haven 2 space station up and running by the time the International Space Station retires in the early 2030s. And we'll discuss more about their space station modules in a moment. And the company plans to launch a pathfinder called Haven 1 in 2027, and that was delayed from this year. Haven 2's first module will lift off in 2028, additional modules going up every 6 months thereafter for the next 4 years. I think a lot of those dates and timelines are up in the air at the moment because of NASA's pivot on commercial space stations. But before we get into the analysis, let's bring up one other article that has a few quotes I want to read out. So this is from Payloads Space, and it's the same story about Vast launching a satellite bus business line, but there's a few quotes here from the CEO of Vast. And Max Hout, the CEO of Vast Space, is saying that the new business line is not tied to proposed changes announced in March to NASA's commercial space station procurement as the ISS nears the end of its service. So this is referring to NASA's ignition event in March, where NASA pivoted to a moon base, cancelling or pausing the Lunar Gateway, whichever way you want to look at it. But basically the Lunar Gateway went away, and NASA at the same time said they don't believe there's a viable private commercial market for space stations. Instead, they're just going to propose a core module added to the ISS, and commercial space station vendors are expected to dock to that core module, which is a massive change for these commercial vendors. As I've said in previous videos, I don't think that's a very good idea, and I don't think the commercial vendors want to do that. So we'll just see what happens with that. Just reading some more of the article. We've been working for 3 years on a high-powered satellite bus that just has humans inside, he said. There are just 2 new pieces of tech that will be required for the bus: high-power, low-cost solar arrays and electric propulsion. And Max Hout goes on to say these capabilities would be necessary for Haven 2 anyway, so they're already in development. So that is the situation with Vast Space. They're working on Haven 1, which is their minimal viable product commercial space station. That's launching in 2027. They're working on Haven 2, which is a larger free-flying space station that was intended to compete for NASA's commercial LEO destinations program. But now NASA's pivoted to installing a core module on the ISS, and commercial vendors are expected to dock with this new core module, which won't be available until 2029. So I don't think any commercial space station is happy with the situation from NASA's pivot. There's very little money on the table, $250 million a year, which is really insufficient even for one space station, never mind multiple ones. So Vast Space, Starlab, Axiom Space, Orbital Reef are all up in the air. There really isn't enough money to go round, so it doesn't surprise me that Vast is pivoting towards satellite buses and to orbital data centers. It seems to make a lot of sense to me. So we do have an image of the satellite bus, and this is a 15 kilowatt satellite bus and suitable for orbital data centers, Earth observation, or communications. And it builds on this demo mission from Vast, where they put into orbit a satellite with avionics, solar panels, and other systems that would be deployed on Haven 1. They've already qualified some flightware in space, so they're making quite a bit of progress. They're also working on private astronaut missions to the International Space Station. NASA has accepted one mission from Vast Space. They've also accepted a mission from Starlab and Axiom Space. So there'll be at least one flight to the International Space Station that's organized by Vast Space. Haven 1 is expected to fly on a Falcon vehicle, a medium lift vehicle, next year. It fits inside the fairing. Once it's deployed in space, Crew Dragon can send 4 astronauts to dock with the space station, and they can spend a couple of weeks on the module doing science. There's a number of payload lockers in Haven 1. You can see some astronauts there. There's actually 10 payload slots, and we have a schematic of Haven 1. So you have the payload slots at the end, and then you have the docking port at the front, and there's some sleeping quarters and storage area, and then the common area with a table, and there's a nice view of Earth from the window. So that's what Haven 1 looks like, and that's an image of outside with a Crew Dragon docked. And we have a video of Haven 2. This is proposed space station for NASA post-ISS. This was for the commercial LEO destinations program, but as I said, that's now up in the air. NASA's pivoted, so there will be no free-flying space station supported by NASA. So Vast Space could go ahead and do their own private commercial space station based on Haven 2, or they could pivot towards NASA's approach and have a module dock with the core module on the ISS. So anyway, that's Haven 2. It's a stretched version of Haven 1. So you can dock multiple modules together and chain them all together to support a very large space station in microgravity. And also, Vast Space is assembling a core module lifted on a Starship, which will allow a small amount of gravity, spin gravity. The idea is you'd undock the Haven 2 modules and then attach them to the core module, which will spin, creating a small amount of gravity. Very, very small. But that's that's artificial gravity space station. And you can keep adding modules until you have a very large space station. This is in the 2030s with a nice view of Earth. So they have some very big plans and a robotic arm as well. And they've also been working on other hardware, including a large docking adapter. This is much larger than the docking adapters on the ISS or Crew Dragon. And it has soft capture and hard capture attachment points. And as you can see, it's much larger than the international docking adapter. You can chain them together using this large docking adapter and move large equipment and people easily through from one module to another. So that's very exciting from Vast Space. So let's move on to the second story this week. And our second story is on a LinkedIn article by the head of ESA, Josef Aschbacher. So let's just read what he had to say. I'll bring it up. Here is Josef Aschbacher. He's the head of the European Space Agency. And the title is, Are we pilots or are we passengers? I'll just read the highlighted areas. He said that the decisions by NASA to pause Gateway, that's the Lunar Gateway, and cancel Mars sample return mission disrupt Europe's lunar exploration plans. Europe has become too exposed to decisions beyond its control. Europe must decide whether it prefers to be dependent on others to send its explorers into space or to assume its role as a fully capable space power. As the head of the European Space Agency, ESA, I am convinced that autonomous human spaceflight is not a luxury. He goes on to say that Europe's political decisions have always fallen short of pursuing full autonomy in human exploration, a hesitation which has had lasting consequences. And he's referring here to billions of euros of European taxpayers' money that's been wasted on joint projects with NASA that have been cancelled. He goes on to say that ESA has consistently translated European ambition into operational reality. and that this experience is precisely what gives Europe the credibility to be the maker of its own future in exploration. ESA's reputation for reliability has been built by delivering on its commitments on time and at the highest level of performance. That is why partners consistently choose to work with ESA. We must be mindful to not let cooperation slip into dependency. Diversified international partnerships and strengthen autonomous capabilities to avoid single points of failure. He goes on to say that Europe should decide to act independently to protect our investments amid geopolitical uncertainty. And lower down, he goes on to say about acting decisively in response to a geopolitical landscape that keeps transforming. We must use this challenging moment and turn it into an opportunity to redefine our position. There is no room for delay. If we started today, it would still take us many years to build autonomous capability. We must act quickly. The cost of inaction would far outweigh the necessary investment. If not now, then when? The choice before Europe is clear. Do we pilot or are we merely passengers? We have everything we need. So that is an article by the head of the European Space Agency, Josef Aschbacher. And before we talk about that, there's one more article on the same topic that we can have a look at and then we'll discuss. So this is from the EuropeanSpaceflight.com, which is an excellent resource of news on the European space sector. Here in this article, it says that the European Space Agency Director General, Josef Aschbacher, argued that Europe must develop an independent human spaceflight capability and that the agency is reliant on its barter arrangements with NASA to secure seats for its astronauts. In 2023, the agency launched its LEO Cargo Return Service Initiative to give sovereign European space cargo transport service capability. ESA required all eligible vehicle designs to be adaptable for future crew transportation. And in November 2025, the agency launched a crew launch abort demonstrator initiative. With a system like this fitted to Ariane 6, Europe would close the loop on a crewed launch capability. And in February 2026, ESA launched a call for a study to explore the development of a European-led space station. I've talked about this already. I've done multiple videos on a European-led or ESA-led space station with international partners like Canada and Japan. It seems like the head of the European Space Agency, Josef Aschbacher, also wants Europe to be an independent sovereign space power. And the obvious thing to do is to build a space station in low Earth orbit with crew and cargo vehicles to sustain it. And as he said, that will take many years, but the best time to start is now. So there's a number of meetings this year to talk about the budget and so on. So hopefully by the end of this year, once we have the results of the post-ISS study by ESA, they will recommend scenario 3, which is a European-led space station with international partners. That seems to me the only viable option. The first two options or scenarios were to use commercial space stations, either relying totally on those stations or adding European modules. But both of those are dependent on a viable private commercial space station sector, which doesn't seem very likely at the moment. NASA doesn't believe it. It's not going to put the money behind it. And NASA is really focused on the moon at the moment. So I think a European space station is the way forward. Okay, on to our final story this week. And this is on Astrolab's Lunar mission. So we have an X post. Let's just read that here. Put myself in the corner. So Astrolab says, we're excited to welcome payloads from 4 NASA centers on board our Flip rover's mission to the moon. They include, and in the post it lists the payloads and there's some images. So let's just read an article on their website to get a better idea of the payloads. So this is from Payload Space, and the title is Astrolab unveils payloads flying on Flip lunar mission. Astrolab is headed to the moon this year. The company revealed some of the payloads flying on board its Flex Lunar Innovation Platform, or Flip rover. And the payloads include a multicolor camera and radiometer from NASA's Ames Research Center and Interloon to estimate the concentration of helium-3 present in the lunar regolith. So Interloon is a space startup that has a business plan to capture helium-3 on the lunar surface and to send it back to Earth for sale. There's also a laser retroflector which will be used for precise tracking of the rover's position without the need for power or maintenance. In addition, there's a lunar dust level sensor to quantify the impact of lunar regolith or lunar soil on lunar systems. And finally, there's a lunar LiDAR demonstrator to create high-resolution 3D maps of the lunar surface. And the article goes on to say that Astrolab's first mission to the lunar surface, FLIP, will act as a building block for larger vehicles. Astrolab is building towards its larger, more complex, flexible logistics and exploration rover, or FLEX. FLEX is targeting future commercial and Artemis program missions and is designed to support astronaut operations, logistics, construction, and more. And we have a quote from the CEO of Astrolab, Jarrett Matthews. With FLIP, we can provide a nimble, mobile platform that enables multiple NASA investigations in one mission. Together, these efforts will help pave the way for Artemis astronauts to explore more of the moon. So that is the article by Payloads Space, and we have a few images. So this is the FLIP rover. This is a smaller version of their Flex rover, and you can see a retro reflector on the rover. You can bounce lasers off this and get very precise positioning and distance information. So Astrolab is working on their Flex rover, and here it is. As you can see, it's a bigger vehicle and it supports 2 crew, or it can be used autonomously or teleoperated. And it has a robotic arm, so you can position payloads on the lunar surface or collect payloads. They're also working with startups to add tools to the Flex rover. You can see some kind of excavator tool at the front here. I think this is working with Astroport. They're working here with Voltager to deploy a 25 to 50 kilowatt solar array system, which is quite powerful. And we have a video of the Flex rover. So the system's been under test for a long time now. It's been tested by NASA, it's been tested in the desert, and many lunar startups are working with Astrolab on the Flex rover. I think Interloon and Astroport and Voltager, and perhaps more as well. It has deformable wheels for going over rocks and divots, and plenty of slots for tools and samples. So Astrolab's Flex rover is going to be a very capable LTV or lunar terrain vehicle. It's one of the 3 LTVs NASA is considering. So you have the Astrolab Flex rover, you have Intuitive Machines Moonracer, and you have Lunar Outpost Eagle rover. As I mentioned recently, Lunar Outpost are also developing a smaller, lightweight vehicle called Pegasus. The idea is that NASA will be pivoting towards cheaper, less capable, descoped rovers for phase 1. So Pegasus is one of those descoped rovers. We'll see whether Astrolab will descope their Flex rover to get a simpler, cheaper, less massive rover on the surface of the moon quicker for phase 1 of NASA's new phased approach to going back to the moon. So anyway, that's all the space news this week. So thank you for watching, and don't forget to leave your thoughts and opinions in the comments section below, and I'll read some of those comments out at the live stream at the weekend. So thanks for watching, and I'll see you next time.